Skeletal muscle fibers contract by getting a signal from the nervous system. The specialized intercellular connection that acts as a communication link between the two is a neuromuscular junction. Skeletal muscle fibers are controlled by nerve cells called motor neurons. These are nerve cells that have many branches and axons that action potential, or AP, travel down. At the end of the branches are synaptic terminals. Synaptic terminals contain vesicles filled with acetylcholine, or ACH, which is a neurotransmitter or chemical that communicates with other cells. The ACH enters a space called the synaptic cleft. This area, called the motor end plate, has receptors for ACH to bind to. Both the synaptic cleft and motor end plate contain acetylcholinesterase, or ACE for short, but this will be explained later. Because ACH binds to the receptors, an action potential, or an electrical impulsor signal, is created and spread over the sarcolemma's surface. The AP also travels down the transverse tubule, or T-tubule for short, which excites the terminal cisternae. This excitement causes calcium gates to open, which releases calcium into the sarcoplasm. Now being free, calcium can bind to troponin located on the thin myofilament, as you should know holds actin. When calcium binds, tropomyosin, which blocks actin's active sites, exposes those active sites for binding. This is when the sliding filament theory comes into play. Cross-bridge formation occurs. Let's say myosin heads on the thick filament have an affinity for actin molecules, so they attach to them. Myosin, being greedy, will pull the actin, which causes thin myofilaments to slide towards the sarcomere. I must clarify that the motion isn't exactly sliding, but it appears that way because it's so small. The pull makes the sarcomere shorten, as well as the myofibrils and muscle fibers, and the zone of overlap increases. An example of seeing this in action would be an arm muscle flexing. The contraction stops when AP isn't made anymore, causing a reversing effect. ACHE removes ACH, AP transmissions end, calcium returns to the SR, and calcium gates close. Without calcium to bind to troponin, tropomyosin covers the active sites of actin. Thus, thin myofilaments slide back to their resting state.